A lot of you missed number 14. It depends on what version of the test you got. Sometimes the answers were scrambled, or I added a minus sign somewhere, whatever. The concept's the same. So a lot of you surprisingly got this wrong, and I think there was some level of not doing the problem as thoroughly as you should get used to doing problems. So when you do this, you go, OK, scientific notation, I have to have that first digit be between 1 and 9. So I'll try to get it smaller. So I'm going to move the decimal point from here to here to here to here to here. So that's 1, 2, 3, 4 places, right? So the answer is going to be 8 times 10 to the 4. But the question is, how do I preserve significant figures? Because this only has one significant figure, right? So like almost all of you selected this answer, like 8.0 times 10 to the 4th. How many significant figures does that have? It has 2. C has 1, right? So that's really a big deal, right? Like if you had to pick between A and C, clearly C is the better answer because it has the same number of significant figures and it's the right magnitude, right? But there's no ambiguity on this. This is a sig figs class. Which of the following formulas is incorrect? So when we write compounds, none of these have a charge on them. These aren't ions. These are neutral compounds. So the total number of positive charges in these ionic compounds should equal the total number of negative charges. So if you look at the periodic table, sodium is in the first column, and bromine is in the column that's right next to the noble gases. So that means that sodium will have a +1 charge as an ion, and bromine will have a -1 charge. So that means that this has +1, -1. There's a second bromine, so that means -2. So +1, -1, -1. That's a total charge of -1. So this is incorrect. This is a bad formula. Sodium is not going to have a +2 charge. Yeah, I think that's pretty straightforward. Aluminum has a +3 charge as an ion. Chloride has a -1, so that means that this is balanced. This is neutral as well. The rest of them are neutral. This is my mistake that all these are supposed to be grams and they're written as kilograms. I'm sorry about that. But I did write a note on the board and I made an announcement and I annoyed all of you guys about that. So all of these answers were supposed to be in grams, and a kilogram is 1,000 grams. So that means that it should be this answer. Yay, right? 10 to the 3rd times 10 to the 1st is 10 to the 4th. So straightforward. This should have been grams. I made the note on the board. It was pretty much straightforward. Which of the following is a homogeneous mixture? All right, let's think about what that means. Homogeneous. It means same, like. So evenly distributed. No portion of it is different than the other. Like we all kind of know what homo and hetero mean, right? Homosexual means someone who likes someone of the same gender. Heterosexual means someone who likes someone of the different gender, right? Homo, sameness, hetero, differentness. So for example, like soil, if you look at soil, it has different regions of different stuff. So it's clearly not homogeneous. What does mixture mean? A substance, a pure substance, is one kind of molecule throughout. So water, for example, is a pure substance. Homogeneous mixture, jelly beans are not homogeneous. Copper metal is a pure substance. It's just copper metal, literally copper, 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 onward. So the only thing that really fits this is gasoline, because gasoline is a mixture of different octanes, and nowadays they add all kinds of stuff like Techron or whatever. A nucleus has a whole number of protons and a whole number of neutrons. It doesn't have a fractional number. It's like what it has in it. It'll only have like 10 or 11 atomic mass units. So the probability of you picking this mythical one that has a fractional mass all by itself of 10.81 AMU is 0%. Yeah. You should be thinking it's either going to be like 10 or 11, and this is just an average of 10 or 11. The answer is B, yes. There's no chance, 0% probability, not going to happen, that you find a boron atom with 5 protons and 5.81 neutrons. You only have 5 or 6 or 7, a whole number of neutrons. Quantum mechanics. You guys have heard that term, right? Quantum mechanics. Quantum meaning like counting numbers. Quantified, not average numbers, not continuous numbers. So you count like it's either 1 neutron, or it's 2, or it's 3, or it's 4. It's never like 0.5 neutrons. Titanium 4 oxide has the formula. Okay, so titanium 4 means that we have on the titanium a +4 charge. Each oxide, that's an oxygen anion. You look at the periodic table, you see that it's in the column that's 2 away from the noble gases, so it has a 2- charge. How many 2- charges does it take to balance a +4 charge? All right, someone threw a gang sign at me, so I'm assuming that's a 2. Yeah, so which one of these has the lowest ratio of 1:2 titanium to oxygen? This one does, right? A. The correct name for iron oxide, FeO, is, there's just 1 iron there. There's no 2 here, there's no 3 here, nothing. It's just 1 iron. So that means the iron has to be +2 to make this whole thing neutral. So iron 2 oxide is the best one. Iron is one of those type 2 or ambiguous elements that has multiple charges possible. That's why you have to specify iron 2. And on the handout that I gave you guys, there was a table that had specifying like ferric versus ferrous. So you had a clue if you looked at the table whether or not iron was one of the ones where you can get away with just putting iron, or if you have to specify iron 2. You have to specify iron 2. So if someone didn't tell you FeO and just said iron 2 oxide, you should be able to reproduce that the formula is iron, like Fe, no subscript, O, no subscript. And if I give you this exact question again, you should be able to get that it's iron 2 oxide as a name. The correct formula for iron 3 phosphide. Any ideas? What's the phosphorus is not the column that's right next to the noble gases, not the one that's next to that one, but it's the 3rd column from it. So it has to have a 3- charge. What's the formula going to be for iron 3 phosphide, since phosphide has a 3- charge? Will it just take 1 iron 3 to balance a 3- charge? So iron 3 means iron 3 plus, and phosphide is 3-, so it's just a 1-to-1 ratio that makes it be charge neutral. A certain isotope, X plus, contains 54 electrons and 78 neutrons. What's the mass number for the element? Okay, so let's work through this. If it's X plus and it contains 54 electrons, how many protons does it have to have? It has to have 55, right? It has to have 1 more proton to have a plus charge. So if it has 55 protons and 78 neutrons, what's the total mass number? What's 55 plus 78? That's a hard one. I don't know if I can do it in my head. It's 133. So the answer is E on this one. Okay. So I'd like to do some more balancing equations with you guys before we do clicker questions. So if that's okay, let's do this together. So if I was to give you this equation and I was to ask you to balance the equation, you should be able to do this on an exam. Right? So like, let's start with no coefficients. What you should do if you want to be systematic about it is you make a grid. A lot of students write a line down the middle, like where the arrow is, to separate reactants from products. But what I do is I just go, okay, let's go element by element. Somebody suggested that I should go with like the most intertwined molecule first, the one that has like the most shared elements with different stuff, because like that's what's going to change the most things. Let's look at potassium sulfate. So for potassium, that's like the only compound that has potassium in the reactants, right? So there's one currently, one equivalent of potassium sulfate, and there's 2 potassiums in there.
I got a question.
Yes?
Is that
I think this is a double displacement reaction, technically. So I'm not terribly, I think you need to know this for Alex and stuff, but notice that there's like two ionic compounds, and what they do is they like switch partners. So like potassium was with sulfate, and lead was with chloride, and now lead is with sulfate, and potassium is with chloride. Right. Single displacement would be like just lead and potassium sulfate turning into lead sulfate and potassium. So like that's like you're at a dance or something, and there's two people dancing, and you just cut in, So you displace the other person dancing. I hope that helps. Okay. Either it did help or you just got annoyed. So either way, it works for me. Sulfur, there's only one molecule that has sulfur. So that means that I just look at that molecule. So there's only one equivalent of it. And there's one sulfur in there, so just one sulfur. Oxygens. How many oxygens are in the sulfate? 4. And there's just one sulfate, so it's going to be 1 times 4. So that's 4. Chloride. How many chlorides? Yeah, there's 2 in lead chloride, so 1 times 2. So lead, there's only one lead, right? Just one equivalent of lead and lead chloride, and there's just one lead chloride, so there's just one. So over here on this side right now, we have 1 lead. That's good. And for the products, we have 1 chloride. And for the potassium, we just have 1. Did I do that right? I hope so. And the oxygens, there's 4, right? So 1 times 4, because there's just one equivalent. That first number, I'm trying to be consistent. I'm trying to make it the number of the compound, like the number of equivalents, the number of moles, the number of molecules. So like if there's nothing there, it's a 1. But we'll change it because it's not balanced. So when I look at this, right, the O's are the same, so I didn't like change the number of O's, so that's good. Sulfurs are the same, that's good. Leads are the same, that's good. Chlorides are different, though. There's 2 chlorides we started with, and now we're ending with 1. That's weird. So I have to change the number of equivalents of potassium chloride. So I'll make it 2. And that'll change the number of chlorides from 1 to 2 of them. And I'm probably making mistakes all over, so really yell at me if I have problems. So how about potassium? Did I change potassium by doing that, by making it 2 equivalents of potassium chloride? I did. So now there's 2 of them. 2 potassium chlorides, so that means that there's 2 potassiums. So this thing is now officially balanced, unless I made huge mistakes. And I say that it's officially balanced because literally every element in this equation, there's the same number of them in the reactants as there are in the products. So 1 lead, 2 chlorides, 2 potassiums, 1 sulfur, and 4 oxides, 4 products and reactants. So we're done. Right? So hooray! It is a long and obnoxious process, but it is doable, and if you just get good at counting how many elements there are on either side, you know when you're wrong. You know when you still have work to do. The only other thing to check is to make sure that the ratio of the moles, like the numbers, can't be reduced. So if this was like 2, 2, 2, 4, they're all multiples of 2, and I could divide them all by 2 to get the lowest whole number ratio. So since this is 1 to 1 to 1 to 2, I'm fine, because 1 is as low as you can go.